First of all, thank you so much for being here.
My pleasure. Thank you for the invitation. It's my first visit to this college.
Lovely. I hope you enjoy your
I'm
time
sure.
here.
Yes, thank you.
So to start things off, I would love to know what was it like growing up for you? What were your hobbies? And what did you spend a lot of time doing as a child?
So, as a child, I grew up in Northern Ireland, in the countryside, quite rural, quite a big house and quite a lot of ground around it. Eldest of 4 children. My father was an architect. My mother didn't have a job. She saw it as her job to be in charge of the household and look after the children and so on. My father sometimes, not when I was very young, but by the time I was 8 or 9, my father would sometimes take me with him as his assistant when he went to survey a site where a client wanted a house built. So I got to help him with surveying the site, seeing how steep or how flat it was and how big it was, so that he could properly design the building that had to go on it. So that was my first introduction to practical science. I was probably about 8 or 9 when I started doing that.
Right. Did you come across astronomy when you were young? And when you came across astronomy, was there a moment that made you think, this is it, this is what I want to do?
Yes, there was quite a strong case of that. It didn't happen till I was about 11, probably. My father was very widely read. He had fantastic general knowledge and brought home all sorts of interesting books from the public library. And one day he brought home a book on astronomy by Fred Hoyle, who was writing a lot of books at that time and writing them very well. I was by this stage just into secondary school, and we'd started doing science. I had a battle to get into the science class. Girls did cookery and needlework, boys did science. But my parents and the parents of 2 other girls fought for their daughters to do science. And we did physics that first term, chemistry the next term, which was okay, not as good as physics, and biology, which was, here's a flower, draw the flower, label the parts. You've done that, good. Here's another flower, draw the flower, label the parts. I hope that's not science, and had a prejudice against biology ever since. Physics was always my best subject. So I was clearly heading to be a scientist. And my father helped that training because when I went with him as his assistant surveying a site, he always went round in a circle. So he'd survey that bit of land, that bit of land, that bit, that bit, that bit, that bit, that bit, and end up back where he'd started. And then going home in the car, he would allow me to reduce the observations, which were measures of height. And I'd say, Dad, we ended up 10 foot higher than we started. No, we didn't. Check your arithmetic. So I learnt about design of experiments as quite a young child. So it was a good upbringing, yes.
And what about astronomy? When did you first come across it?
My father was very widely read and brought home all sorts of books from the public library. And they'd sit on a chair, on a table beside his chair, and I would sort of scan through these books. And one day he brought home an astronomy book by Fred Hoyle, who was a well-known writer at that stage. And I thought, that looks interesting, and removed that book to my bedroom to read. And at school, we were doing motion in a circle, centrifugal force, centripetal force. And here I'm reading Fred Hoyle describing the rotation of galaxies and the centrifugal force and the force of gravity counteracting the centrifugal force. And I suddenly thought, oh, I could be an astronomer, because that stuff really grabbed me. Then somebody said to me, you know, astronomers work at night. Because at that stage, it was mostly optical astronomy. There was very little at other wavelengths. And I thought, oh, I need my sleep. I don't function if I don't get my sleep. I can't be an astronomer. And then I got to hear about astronomy at other wavelengths, particularly attracted by radio astronomy, which you can do day and night. So you keep office hours, more or less. Right, I'll be a radio astronomer. So from about age 13, I was saying, I want to be a radio astronomer.
That is very impressive. You figured out at the age of 13 that.
I was very lucky in the books my father brought home from the public library.
That's very beautiful.
Yeah.
What are some questions or topics that excite you or intrigue you today?
Well, what has happened during my lifetime? When I started, radio astronomy had barely started. There was optical astronomy, radio was beginning, no X-ray, no infrared, no ultraviolet. It was really very limited, and it was mostly optical. So I've been excited to see all these new wavelengths open up, particularly things like X-ray and gamma ray, which give us high energy astronomy, which seems to be fairly different from what the optical and the infrared astronomers study, for instance.
Mm-hmm.
So it's been a really exciting ride, seeing all these new wavelengths of astrophysics open up, and our knowledge of the universe just grow and grow.
Coming to your story of discovering the pulsars, I think it's an absolutely fascinating one. And what I wonder about is when you saw those unusual data points, what went through your mind? What did it make you think? And how did you feel?
I had built the radio telescope along with some colleagues, the radio telescope I was using. So I knew the telescope fairly well. I understood its behavior, which was quite important. And I could recognize that this signal was something different. It took me a little while to discover it was pulsed, because the original observations didn't have the time resolution to show the pulses. But I knew there was something curious there that didn't look like anything I'd seen before. And then with the high time resolution comes pulse, 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 pulse. And oh my God, what's this? My thesis advisor was very cautious. He assumed I'd wired the telescope up wrong, or it was interference, or it was this, or it was that. And so as a third year, I guess I was just into my third year of a PhD by then, I had to convince my supervisor that my observations were sound.
Mm-hmm.
And that took a bit of time, but I did. So he believed me. But the snag was then we just had one of these objects giving funny signals, and that's really disturbing. But the stars keep to the 23-hour, 56-minute day, which is why we've different constellations in the night sky in summer and in winter. Astronomical sky shifts gently past the solar day, and this thing kept its place amongst the stars. Absolutely, I could not make it budge. Which means if it's interference, it's somebody keeping a 23-hour, 56-minute day, which is not normal. Only astronomers do that. So did some other astronomers have some program going that could cause interference? It was quite a puzzle. Finding a second one was a huge relief. It was in a totally different bit of the sky, and it had a very different pulse rate. But there aren't two lots of astronomers doing crazy things and causing interference that appears at different parts of the sky and with different pulsation rates. This really has to be something astronomical. But it was quite a few months of very careful work, making sure that what I was looking at was genuine, was astronomical. And then when you find more than one, it begins to get better.
When did it sort of hit you that I have discovered something, and I've discovered something really important?
Well, I knew I'd discovered something as soon as I saw pulses. I believed it was cosmic. I'm pretty certain it wasn't interference or anything like that. I'd worked too much with the telescope and the data by then that I could tell the difference between man-made interference and proper cosmic signals. So that was quite exciting and perplexing. Your reaction is, what the heck is this? It's because we'd seen nothing like it before. Nobody had. And it's not easy to explain straight off. You can't say, oh yeah, that must be a da-di-da-di-da. There wasn't anything that I could say, oh, that's a so-and-so. So it was quite surprising. It also needed a lot of tenacity and a lot of hard work.
Was there any theoretical prediction of pulsars before you discovered it?
Theoreticians, you take a big group of theoreticians, some of them will have crazy ideas. So yeah, there were one or two crazy ideas out there, which the theoreticians had been discussing. And I think that's how Fred Hoyle, when he first heard of these things, was able to say immediately, that's a neutron star. Because the theoreticians had been talking about this mad idea of how when a big star explodes, its core gets compressed to fantastic densities and becomes largely neutrons. So they're known as neutron stars. The protons in the center of the atom and the electrons around the outside get forced together. And so the positive and negative charges neutralize each other, and you get this lump of neutral stuff.
Right. And what an amazing thing to have Fred Hoyle comment on your discovery, given that you started out with this.
It was interesting. It was also slightly perilous. There was a bit of a war going on, war in inverted commas, between Fred Hoyle and the radio astronomers. Fred Hoyle's picture of the universe was what he called continuous creation. He did not think there was a beginning. He thought the universe kept regenerating itself. And the data that some of the other radio astronomers were delivering suggested that the Big Bang model was right, that there was initially everything compressed in a tiny volume and then went whoosh. Big Bang, slang, but there was a Big Bang. And we still see things moving apart. We still see the universe expanding from that Big Bang. Turns out the Big Bang picture is correct.
Right. When you sort of study about the universe for so many years, does that change the way you look at the world or your perspective on life or things in general?
It certainly makes for a very exciting job. I've been involved in quite a few exciting bits of astronomy, one way and another. After the discovery of pulsars, perhaps the next most exciting time was when I was working in X-ray astronomy. With X-ray astronomy, you have to use satellites because the Earth's atmosphere cuts out the X-rays, which is good for our health. But it makes rather expensive astronomy if you can't observe from the surface of the Earth. You have to get up above the atmosphere. And for a while, I had a job in X-ray astronomy, and that certainly was exciting as well, because that was a rather more recently opened waveband. So it was still very new, lots of things to discover.
Right. So you played around in radio and then X-ray. Are there other fields or other wavelengths you dabbled into?
These moves happened because as I finished my PhD, I got married. And I got married to a man who worked in local government, county councils, city councils, things like that. And the way you get promotion in local government is to apply for a job that's higher status in another part of the country, another city, another area. And so my husband would say, right, I've got a job in such and such a place, and I'd look for an astronomy job somewhere near that. And then after 5 years or so, he'd say, it's time I moved. So he'd start applying for jobs. And he'd say, there's a job going in Hartlepool. Is there anything astronomical anywhere near Hartlepool? And if there wasn't, he wouldn't apply. If there was, he'd apply, and if he got the job in that city, then I'd write a begging letter to the nearest physics or astronomy place saying, might you have a job? And indeed, sometimes a part-time job because we had a child. So I moved from radio astronomy as a PhD student. My first postdoc was in gamma ray astronomy, right the other end of the spectrum. And then my next job was in X-ray astronomy. And my next job was in infrared and millimeter wave astronomy. So I've covered a lot of the spectrum, one way and another. At that point, the marriage fell apart. And I thought, right, this is a silly way to do it on several counts. It would be better to be focused on the astronomical objects, not the wavelengths.
Mm-hmm.
So I became interested in compact objects and said, I'm going to study those compact objects at whatever wavelength will give me useful information about them. So some of it was X-ray astronomy. We did a bit of infrared, we did some millimeter, we did radio, observing at many, many wavelengths to try and understand this compact object, which was frequently twinned with an ordinary star in what we call a binary system. So they orbit each other. They're twinned. One star is quite normal. The other one is one of these compact objects, which turns out that it used to be a very big star. And it was there quite early on in the life of the universe. Because it's a big star, it's got higher temperature in its middle. It runs through its life cycle quicker, explodes or whatever, and you're left with an interesting remnant, which is what we were often studying.
So, what are other extreme dense objects like neutron stars? I suppose black holes.
Black holes were the other things. And when I worked in X-ray astronomy, we discovered that binary system, twin stars, an ordinary star, and either a black hole or neutron star twinned with it and the two orbiting each other, that these could quite often give X-rays, sometimes gamma rays, certainly radio, some optical, maybe infrared, ultraviolet as well. And it was important to study them over a wide range of wavelengths to get full understanding of what this pair of stars was actually doing.
You talked about your PhD and postdoc and your sort of data analysis and experimental stuff. And I believe it was all like hand drawn and manual and a lot of doing stuff on hand.
Computers by the time I moved into X-ray astronomy. The computers took a whole load of punched cards. I don't know if you've ever seen punched cards.
Yes.
So we had a great big stack of punched cards. Don't drop them. It's one hell of a job to get them sorted back in the right order. And you'd put the cards into a sort of hopper and the machine would read them. And they go into the computer and you'd program the computer and you'd given it the data. And with luck, in an hour or two, there would be some printout for you telling you it had worked, it hadn't worked, what the answer was, so on. Yeah.
But that is quite advanced from your pulsar story,
Yes.
where you were.
Whereas no computers, absolutely. But it's a long way from today's laptops and things, isn't it?
Right. What do you think of today's data analysis, which is all about digital, automized, even AI?
Yes.
What are your thoughts on that?
I'm sufficiently old that I struggle a bit with some of the digital stuff. I can do it mostly, but occasionally get in a twist. It's almost gone too digital for me. Yes, but thank goodness we had got that far when COVID happened. If we hadn't had computers and the digital skills we had with COVID, we would have been much, much worse off.
Right. So another question I wanted to ask is, if you think pulsars were being discovered today, would things have been different?
I think word would go round faster. We have faster communications in science these days. Back then, it really depended on people traveling, from London to New York or Cambridge, Massachusetts, or wherever,
Mm-hmm.
carrying news about what somebody back in Britain has just found. There were journals, but there was quite a lag between you sending in a paper and it actually being published, and then that hard copy reaching all the libraries around the world. But that was the way we worked. Email came later and clearly speeded things up a lot.
So another thing I want to ask is when I I studied a bit of astrophysics when I was doing my physics degree. And when I sort of think about the universe, it's obviously a very beautiful subject to study and think about, but sometimes it's also very overwhelming how massive the universe is.
Absolutely, yes.
Do you experience that feeling too, and what do you
Yes.
think about it?
Yes, it's quite awesome. Particularly, you know, if you see a galaxy and you think that's 100 million stars, maybe there's 100 million planets, maybe only a tenth of that. Let's say 10,000 million stars with planets. That's a lot of planets. Are there people on some of those planets? All those planets? It's both exciting and slightly scary, I think.
So you received the breakthrough prize, and you chose to donate the prize money to support underrepresented groups in physics.
Mm-hmm.
I think it's a very strong and a remarkable step. What led you to make that choice?
Part of my argument was both when I was an undergraduate and when I was a PhD student, I was one of very few women. As an undergraduate, there were 49 men and me in the physics class. As a grad student, I was the only female grad student, but there were a few other women round the place. There were some female computer programmers, for instance. So although I was the only student who was female, there were at least some other women around. And so I've been in a gender minority almost, well, not almost, all my life. You know, it's still the case even in Oxford Physics Department. There are women, but there aren't that many of us. And I'm not saying the place is biased. Particularly when you get to my level, there are few women because when we were students, there were few women students, and larger numbers will work their way through, but haven't yet worked their way through. So I'm not wanting to say that there's gender bias, but because a place is male dominated, it tends to run in ways that suit the men better than suit the minorities, be it the women, the people of colour.
And what do you hope to see for those students who are supported by that fund?
While the first of them have got their PhDs. The first one or two have finished, which is good. And one I know at least has a very good job in France, Spain, on the continent anyway, yeah. I was at her graduation ceremony, which was rather nice. Yeah, so I hope that it will lead to there being better gender balance in physics departments, not just in astrophysics, but right across physics. It's a fairly small contribution to it, I have to admit, because we have a lot of universities in Britain with a lot of grad students and a lot of postdocs. But I hope it will gradually shift the balance.
Yes, I hope so too. And I want to know, what is your favorite thing to observe in the night sky?
I think it's probably the Crab Nebula, the remains of a star that exploded in 1054 AD, which has a pulsar in it, one of the faster pulsars. There was a great puzzle. Everybody knew that the nebula was the remains of the star that exploded in 1054 AD. 1054 is a long time ago. The nebula should have got very faint by now. And it hadn't. What was going on? It turns out there's a pulsar in the middle of it. and the pulsar beam shines on the nebular material and keeps it shining. It's a very neat piece of physics, that one.
Right. Is there a question that people don't usually ask you and something you wish to talk about?
Question that I think I don't get asked often enough is what excites me now. And I'll go back a little bit. When I was an undergraduate in Glasgow, in the final year, we had an hour a week with a staff member in groups of 3. And the staff member that I was allocated to, along with a couple of my male colleagues, was a funny little round man called Ron Drever. And at that point, he had an experiment running to see if the mass of the electron changed as the galaxy went overhead. It's pretty erudite physics, but I sort of grasped it basely. I thought, aha, this man has interests that are quite close to mine, because I'd already identified astrophysics. I'm going to watch whatever field Ron Drever moves into. And not very long after that, he started developing detectors for gravitational radiation.
Mm-hmm.
I thought, oh ho, this is an up and coming field. This is a whole new spectrum that we haven't yet worked in. And so I was watching the development of gravitational wave detectors right from the beginning. I knew there'd be a detection someday. I wasn't sure I'd be there to see it, but wow, it's happened. So that's fantastic. Really, really excited by that.
Fantastic. Okay, I think that's all the questions I had for you today.
Thank you very much. They're
And
super questions.
thank
Fun
you
to
so
talk
much
with
for
you.
your time. Thank you for answering them.
My pleasure. It's been fun for me. So thank you very much for the opportunity. And it's been great to talk with you.
Thank you so much.